Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us move on to the today's class. Actually today the new topic in number system. According to your point of view, we need to discuss about factor and divisors. Am I right? Yeah. What is a factor or what is a divisor? So almost both are same, right? Factor is nothing but divisor. So both are similar words. But if you take any number, according to the fundamental theorem of arithmetic, we know that any composite number can be expressed as product of its primes and the prime factorization is unique. Am I right? Every composite number can be expressed as product of primes and its prime factorization is unique. So, to write any composite number in the form of its factors or product of its factors, we are using the prime factorization method. But how many number of factors or how many number of divisors of a number or sum of divisors of a number, product of divisors of a number? Let us discuss about these concepts today. What are the concepts here? Number of divisors, sum of divisors and product of divisors. Okay, right. For example, what is a factor? When you multiply any two numbers, will give the product, and these two numbers are factors to the product. Am I right? These two numbers are factors to the product. Nothing but if you take 3 into 7, 3 into 7, which is nothing but 21, where 3 and 7 are factors of 21. So if you want to write all the factors of 21, we have to go through each table from 1. So 1 21s are 21. So 2 table 21 won't come, 3 sevens. So what are the factors here? The factors of 21 are 1, 3, 7 and 21. In case if you take the 3-digit number, then the number of factors will be increased. That means we need to check each and every table, 1 table, 2 table, 3 table, like that. It is somewhat difficult process for us. So for that, I am going to discuss about the number of divisors in a simple manner. Number of divisors of a number in a simple manner. Let us compare both the general method and this what is the method I am going to discuss about that method also. Okay. So what is the standard form of a number? Simply standard form of a number is nothing but we have to write that number as product of its factors. So simply we should write every composite number can be expressed as product of its prime factors or product of primes. Okay, right. So for example, I am taking 12. So 12 can be expressed as 2 into 2 into 3. This is the prime factorization of 12. Okay, so 2 2s are 4, 4 3s are 12. So while we are writing these numbers, these prime factors as exponential form, so here 2 is multiplying itself 2 times, so we can write it as 2 square and this is 3 power 1. So this is the prime factorization of 12. So first we can write 3 power 1 into 2 square or 2 square into 3 power 1. So order can be different, but the prime factorization is unique. Okay. Yeah. Now number of divisors. For example, I am taking the number of divisors for 24. So by general method, one by one I am taking, nothing but 1 table 124s are 24, 2 table 12 times, 3 table also will come, 3 8s are 24, 4 6 are, and 5 table won't come, 6 4s are. So whenever it is repeated, 4 6 are 6 4s are both are same. So we can stop for checking the factors of 24. Therefore the factors are 1 2 3 4 6 8 12 and 24. These are all total number of factors are 8. But we don't want the each and every factor of 24, but we want only the number of 24, the count we want. How many here? 1 2 3 4 6 8 12 24, nothing but there are total number of divisors of 24 are 8. So now I am going to use the prime factorization method for this. Now 24 can be written as 2 table, first prime number 2 table 12 times, again 2 table 6 times, 2 table 3 times and 3 table 1 time. So this 24 I am going to express as 2 cube into 3 power 1. 2 cube into 3 power 1. Now to find out the number of divisors by using this method, I am writing that, like for example n is a composite number. This composite number is expressed as p1 power n1 into p2 power n2, p3 power n3 and so on, where p1 p2 p3 are nothing but prime factors. Okay na? So for that means a number can have different number of prime numbers, so different number of prime factors. Like 2 1 3 there are 2 prime factors, but more than 2 factors also will get, right? So for that I am taking p1 means first prime number, p2 means second prime number, n1 n2 n3 are respectively their exponents. Same way, now number of divisors we can write it as, the formula for this, n1 plus 1 into n2 plus 1 into n3 plus 1 and so on. By using the formula, what is the exponent here? Number of divisors of 24 is, exponent is 3, 3 plus 1 into second prime number exponent is 1, so 1 plus 1. So here 3 plus 1 is 4, 1 plus 1 is 2, 4 2s are 8. So total number of divisors are 8. Directly we will get the answer. But while explaining it can take some time. But actually, while you're taking the 3-digit number or 4-digit number, this method is very useful for us. Because if it is getting 36 or 37 prime numbers, 36 factors, number of divisors, it is somewhat difficult to us to check each and every table for us. So that we can take this process. Okay? So I hope you understand. What is that? What is the concept we have discussed now? Number of divisors of a composite number. Okay? Let me take one more example now. Now I am taking one more example here. For example, 216. It is a 3-digit number. Then number of divisors for 216. Can we take each and every table 1, 2, 3, 4, 5, 6 like that? It is taking lot of time. So that for reducing the time factor here, let us try to use prime factorization method. Now 2 table. Yeah, 2 10s are and 2 8s are. Again 2 table 54 times. Again 2 table 27. Now 3 table will come because 27 is a odd number, so 2 won't come. Now second prime number 3. 3 9s are, 3 3s are and 3 1s are. So while writing 216 as product of prime factors, it is 2 cube into 3 cube. 2 cube into 3 cube. Then number of divisors, first exponent plus 1 into second exponent plus 1. So it is 4 into 4. There are total 16 number of divisors or number of factors have by 216. Clear? Okay, now let us see the concept of sum of divisors. Before that, let me take before example. What is the example given here? I have taken here. So 24, I have written all the factors of 24. Am I right? So what are all the factors? Total 8 factors. When you add all these factors, so 1 plus 2 plus 3 plus 6 and so on up to 24. If you add all of the factors, what is the answer we are getting? 60. Am I right? Check here. So 24 plus 12, 36, 36 plus 8, 44, 44 plus 6, 50, 54, 57 and 60. The sum of divisors of this number is 60. But if you take the 3-digit number, it is somewhat difficult to find out all the factors, and adding is taking a lot of process for us. So that to find the sum of divisors, we are having the formula like sum of divisors equals to P1 power N1 plus 1 minus 1 by P1 minus 1. So what is P1 here? As we discussed in earlier, that is P1 is nothing but first prime factor of the given number, and N1 is nothing but its exponent, and P2 power N2 plus 1 minus 1 by P2 minus 1 and so on like this. This is completely depends on number of prime factors of a composite number. Okay. For example, 216. How many number of divisors we got? 16 divisors. But while you're observing the number of prime factors, only 2 prime factors. That means we can take only these 2 brackets. If you get the third prime factor, also, we can take P3 power N3 plus 1 minus 1 by P3 minus 1 and so on like that. Am I right? Okay. Now I am checking for same number. What is the given composite number here? Taken composite number, that is 24. I am getting the sum of divisors as 60. Am I right? Now by applying the formula, am I getting the same answer or not? Let us check. But what is the prime factorization of 24 here? 2 cube into 3 power 1. Prime factorization of 24 is 2 cube into 3 power 1. I am going to write here 2 cube into 3 power 1. That means there are only 2 different prime numbers. Let me try to apply in the formula. 2 power. What is the exponent here? 3. So N1 means exponent of first prime factor. 3 plus 1, 4. So 2 power 4 minus 1 by 2 minus 1. Am I right? And the second prime number is 3 power and its exponent N2 value is 1. So 1 plus 1, 2 minus 1 by 3 minus 1. Right. Now check it here. 2 power 4 value 16. 16 minus 1 is 15. So 15 by 2 minus 1 is nothing but 1 into 3 square value 9. 9 minus 1, 8. 8 by 3 minus 1 value is 2. So 2 table in 8. 4 times cancel, 15 fours are 60. So we got the same answer, right? Yes. So by using the formula, there is a time reduced for us, because when you take the 3-digit number, 4-digit number, by the general process, it will take lot of time. So that we are using this formula method. Am I right? So I hope you understand. Let me find out the sum of factors of 3-digit number. What is the 3-digit number here? 216. For this number, by using this same formula, what is the sum of factors of 216? Let us check. So how many factors we got? Prime factors? There are 2 prime factors. One is 2 cube, second one is 3 cube. Now as we apply directly in the formula, 2 power 3 plus 1 minus 1 by 2 minus 1 into 3 power 3 plus 1 minus 1 by 3 minus 1. Let us try to simplify here. 2 power 4 value is 16. 16 minus 1 is 15. So 15 by 1. Same way, 3 power 4. 3 power 4 is nothing but 81. 81 minus 1 is 80 divided by 2. So 2 table 80, 40 times. Therefore, sum of divisors is 600. Am I right? So I hope you understand the concept of sum of divisors. Okay. Let us identify product of divisors. That means we need to multiply each and every factor or divisor of a given composite number. That means if you take the smallest number 24, how we are doing this one? We need to multiply all the factors. 1 2s are 2, 2 3s are 6, 6 4s are 24, like that. There is a huge number will come, right? But this product of numbers or product of divisors we can express in a simple manner, nothing but in exponential form, by using the formula which I am going to give it now. Okay? Let us check. The product of divisors formula is the composite number n whole to the power of number of divisors. We have already found it. Number of divisors in its half time. That is nothing but half of the number of divisors. Half of the number of divisors. Okay. So this is the formula we are using to identify the product of divisors. Clear? Right. Now let me take the same concept here. 24 composite number. So that what is the composite number here? 24. So I should write in the place of n same composite number 24 and its power. Number of divisors by 2. What is the number of divisors we got here? Number of divisors we got here 8. So half of the number of divisors, that is nothing but 1 by 2 into 8, that is 24 whole to the power of 4. If you wanted to find the product of divisors, we can write 24 into 24 into 24 into 24. 4 times we need to multiply for getting the answer. Okay? Or else I am using the same here. What is the 3-digit number I have taken here? 213. Can I apply here by using the same formula? In the place of n, what I have to write? The same number itself. 216 whole to the power of half of the number of divisors. Number of divisors we got 16. Half of 16 is nothing but 8. So half of 16. Nothing but 8. Therefore, product of divisors of the composite number 216 is nothing but 216 whole to the power of 4. Clear? So today's class we have discussed about that number of divisors, sum of divisors and product of divisors, how we are doing from regular class to this class. I hope you learned something new today. Thank you one and all. Have a nice day. Bye bye.